down and then. Yeah. Thank you so much for all the work. Let's
कट कर दिया
short.
Definitely are fine.
जाओ नीचे बुलाने
Utilized by all of the globe, if not India specifically.
Yeah, definitely.
Let's hope let's
Wishing you all the best.
let's hopefully make it out there. Thank you so much. Let's have a little bit please on the hand out there. Yeah, we are not cutting the ribbon. Our tradition is to go something which we always love. Please. Now, ladies.
Come.
Come on.
Yes, sir. How many people are?
Come on, please. Chitra, please. Come on.
Come. Yeah, come here.
Come on, Chitra ji. Come on. You're there.
Come.
To the first one. Oh, yes, sir. You should, please. Get on there. You are on the side. You're the guest of honor. Please, sir. Get it up. Pull it up. Let's get on here. One picture on this side. This is something which we. Chitra, let's get a group picture on this side.
Please come.
Please. Yeah, come on. Oh, yeah. Join us. And, yeah, please.
Wait, sir, wait.
Oh, space weather. Great work.
Yeah.
So these are some of the projects that the students have already defined and worked. Yeah, your own places, right? This is something nice on the space weather knowledge. Your concept.
excuse me
Myself from ECD, second year. So my project is non-GPS navigation. I will be presenting on behalf of my team. So before jumping to the poster, let me give you an overview. What is about this presentation? So the question may have is, why are we creating a system or algorithm without GPS? So we may know the limitations of GPS, that it is wholly dependent on satellites. So the areas where satellite
Oh,
You will know set. On.
Yes, sir. So the poster is here, so we will show the simulation.
Go ahead. Hit it up there.
Go ahead.
Get on the speaker so we all can hear you.
Okay. So, coming to the topic, our project is to simulate a system without GPS. So the main topic is to not to use GPS. So we will use many advanced sensors like LiDAR, which stands for light detection and ranging. It will give us a 3D terrain mapping about our surroundings. Second one is IMU, inertial measurement unit, which will tell us about the acceleration and position. You can see the block diagram here. It has 3 accelerometer, 3 gyroscopes, and on basis of inertial condition, we will get the output, and we may know the position of our aerial vehicle. So the third sensor is optical sensor flow. By using the camera, we will get the distance. We will measure the distance, that how much the drone is flying, or what is the distance between the drone and the space. So the main 2 challenges that we are dealing is that navigation on extraterrestrial planets like Mars, where there is no satellite, so there is no GPS. And second one is navigating on Earth, where the GPS signal cannot reach. Like, for example, dense forest, and for example, tunnels, where GPS signal is unreachable. So we will use our system to navigate through that system. We are also using smart algorithms like Kalman filter, extended Kalman filters, which will help us to fuse the sensors and will give us precise navigation about our vehicle. Second one is RRT, pathfinding algorithm. We can also simulate that. You may see there the 2D version of it. So you can see that there are random tree formation, and after it will reach the goal, which is red point, it will stop and it will give us an optimal path to travel. So that's it.
Thank you. That's a good work in 3 weeks of time. That's a nice one. Any questions, sir?
Yeah, it's a good idea. Basically, they will be useful for the strategy.
We have also so we will be.
But the only constraint is the LiDAR. LiDAR needs high power and the weight. So with the drones, the lifting is very complex. So I think future LiDARs will be much more smaller scales. It's need less power demand. As of now, it's need high power demand. So that is only disadvantage.
We have taken inspiration from Ingenuity, NASA's helicopter. They have applied this, but we are also using this for Earth.
Yeah, we need high lift. So if you have the high power things, then the things will.
Good work. Thank you. Can somebody talk about the weather monitor?
Yeah, it's
No, go ahead.
Good morning, everyone. I am Kutchhi. I'm second year Advanced Communication Technology, and I'm very privileged to talk about my topic, that is Q and V band antenna. As we know about the high communication and the 5G technology, so our topic is about the Q and V band antenna. So let me give you the brief description about the Q and V band antenna. The Q band works on the 33 to 50 gigahertz frequency, whereas the V band works on the 50 to 75 gigahertz. The Q band is used for the exchange of the data between the 2 satellites, and the V band is used for the high frequency, like the broadband technologies. So for in the research, we have find out the 3 main problems, that is the signal loss, atmospheric interference, and the compact design. As with in the signal loss, as the distance increases, the bandwidth bandwidth decreases, and which leads to the less communication. In the atmospheric interference, in the oxygen or the air, the bandwidth signal or the communication cannot be performed properly. And for the compact designs, the antenna should be compact but also work for the efficient for that, we are in the HFSS, we have made the two bands, that is V band and the Q band. We have designed in the HFSS and we simulated, and we successfully got the output of the V band, that is 60 gigahertz, and we can see over in the simulation as well. The V band we have simulated on the HFSS simulator, and we designed, and we also successfully got the 60 hertz frequency.
How much attenuation advantage you will get?
So for the attenuation advantage,
Compared to the expand?
expand for the previous results, it's first it was coming for the 30 gigahertz, but as we changed some designs, we got the 60 gigahertz, and the bandwidth was for 2 gigahertz.
Because no communication with satellites, the space to ground is expand.
Yes, sir.
So there is some attenuation, some advantage also. So if we able to compare with that, so what is the advantage? How much you are getting? So that is study.
Thank you, sir.
Morning, sir. Myself Vishwan. Morning, sir. Myself Vishwan. And today I'm going to present my topic: wearable antenna for GPS applications. So our problem statement was we focused on the military communication system, which challenges face. They face challenges due to the bulkiness and limited range accessibility. So we came up with an idea of creating a flexible wearable antenna where it can be just integrated with your textile fabric, so that it will help them to they don't have to carry any heavy bulky machines, so that it is easier for them to wear watch. So the objective is to design a flexible antenna and to analyze and performance in real world applications. Like every body is reacts different to signals. So we are gonna simulate, or we're gonna test in a different conditions where we can achieve a ideal goal. And we have also optimized for user comfort to enhance antennas designed for seamless wear. So our expected goal is to test on different textiles and get a flexible polymers for durability and signal conductivity. And we are going to ensure the antenna is lightweight and have a long battery life. So we have implemented in such a way, like we have selected some material, and then we have designed a simulation. We have the simulation over there. As you can see, this is our simulation. We have reference paper, and we took some inputs from there, and we created our own antenna. We were intended to get 2.5, but we got, this is the first simulation by the way. We have started working on it, and this is the first simulation which we have done. And we were intended to get 2.5, but we got around 4.5. So I think this is the first step. So I guess we'll get better, we'll do much more working and study, and we'll get it.
Good morning everyone. My name is Shivri and I am a second year student. And this is the title of our project, Development of Software-Based Space Weather Monitoring and Analyzing System. So our main focus is addressing the challenges faced by space weather prediction centers at the atmospheric level, mainly within the ionosphere. So we know that ionosphere is a region of charged particles in Earth's upper atmosphere level, which affects the space weather prediction. As when a satellite broadcasts a signal, it travels through ionosphere and reaches the receiver's end. Whenever it is traveling through ionosphere, the signal deflects due to ions and particles. And due to this deflection, there are errors and uncertainty that is created in the space weather prediction center. So to tackle this situation, to tackle this issue, we came up with a solution, that is dual frequency Navic receiver. So we know that higher frequency signals get less effective by the ionospheric activities and comparatively to the lesser frequency signals, right? So this, whenever satellite transmits multiple frequencies, there are different arrival times for different signals. So the difference, this difference can give us, if we estimate this difference and if we work on it, we can in the space weather package, whatever the problems are created. So the block diagram here gives rough idea of how we can implement the dual frequency NAVIC receivers. So first is understanding the system requirements. Understanding our system requirements also involves understanding the characteristics of NAVIC signals. So firstly, we know that NAVIC operates primarily on two frequencies. One is L5 frequency, and the S-band. The L5 frequency gives precise location or precise positioning, and S-band gives additional coverage or reliability. The second part would be hardware design. Hardware design will include antenna. So for receiving both the signals, we will need dual frequency patch or a helical antenna to receive the signals. Then we will use RS filters to isolate these L5 signal frequencies and S-band. Further steps, we will use analog to digital converters to digitize this signals for further processing. In third step, we will use signal processing software. So there will be a software that will process the signals accurately for prediction. In this part, there is a satellite-specific PRN codes which are provided to L5 and S-band signals. These PRN codes are used to identify which satellites which signals are coming from which satellites. Then the third part would include positioning algorithms. Obviously, developing modern algorithms for more accurate predictions about location and determination. So, user interface development, it should be easy and efficient interface between for interaction between user and the system. And the rest of the steps include testing and validation, optimization, and deployment, connecting all the components for the actual use. So this is what to get information about ionosphere. So first is online databases such as international GNSS services. Third would be test stations and local observatories. In India, we have Gagan stations, and they give real-time data, they offer real-time data. And third would be NAVIC simulation tools. Now here, the graph that we have provided is a reference. We have gotten it from a research paper. So this reference, so the graph explains how our data would look, how we can describe our data about ionosphere. So it mainly has three parameters. There are three main parameters that explain or describe the data about ionosphere. One is TEC, the second is scintillation index, and the third is frequency of F2. TEC means total electron content. The increase in total electron content increases ionization area, which also makes the NAVIC signals experience greater need. Again, an issue in navigation system. The second would be scintillation index. Scintillation index means a variability in intensity of light received from a celestial sources. So when the scintillation index rises, the fluctuations, signal fluctuations increases, and because of this, we get issues. The disruptions are caused in navigation system. Similarly, in frequency of F2, what happens is it improves if the frequency of F2 layer is increased. It improves the propagation condition of radioed signals, but it delays. But again, the signals are delayed, and again that's the issue that is caused in navigation system. So that's the data set.
So you're lucky to talk to the weather expert out there. I will let him say comments last.
Basically, this will any disturbance in the solar disturbance if we have, so which is impacting on the ionosphere in terms of the scintillations, so that we can monitor with this system what we are planning. That is good. So yeah, so other aspects, we have the GNS, we have the IRNSS. So whatever we are looking the irregularities, because of that, the frequency attenuations. So better we have to characterize with the NAVIC as well as GNS. then we have to make the how much it is going to impact. So which is the best one, or we have to use the both to use for the how the impacting is happening in the radio waves in the ionosphere, and which is coming down, how much is impacting on the communication systems.
Okay, sir.
Good.
How do you see the real world application of this?
Yeah,
Do
so
you think-
some it's good, and we have to integrate further downstream and upstream whatever the inputs are coming based on that, because
The accuracy of the space weather package.
That's a good one out there. Considering we are weatherproofing space, these are the projects that we want to do it.
Yeah.
We'll be connected with the right people. Thank you so much.
Thank you so much. Thank
That's a
you.
good one.
Good morning everyone. I am Gurdev Singh Kanchal from Computer Science Engineering, a third year student. And my topic is mitigating geomagnetically induced current, a NAVIC based solution for power grid resilience. Now what is geomagnetically induced current? It is a current induced when geomagnetic disturbance occurs at the ionosphere of the earth. Now this occurs when a charged particle from the space collides with the magnetic layer of the earth. That creates disturbance at the ionosphere, which induces the geomagnetically induced current. Now this geomagnetically induced current flows through the power grids and ground, which can cause many problems like half cycle saturation. Now transformers are basically working on AC current, which causes the magnetic flux to alternate positive and negative alternatively. But when the DC current, that is GIC, is induced at a transformer, then it shifts towards then the magnetic flux shifts towards either positive or either negative, which can cause overheating, relay maze operation or voltage dips. So we have to detect it at low frequency only and inform the operator so that he can take particular action regarding the frequency. Now detecting it is another challenge, because when GIC is induced, then many other harmonics are also introduced along with. Like overheating can also introduce one harmonics. Then if some plant is using excess of power, then that can also introduce some harmonics. So for detecting this GIC specifically, we will use mathematical tools such as Fourier transform and short-term Fourier transform. Now when we apply this Fourier transform and short-term Fourier transform on the current signals we got from current transformers, we will get one graph, that is scalar graph. It's a 2D representation of the signal we are getting from this tools, and then we will pass that graph to CNN model, convolution neural network model. What they will do is they will differentiate the model. They will be trained first, like how a GIC affected signal looks, and they will then be tested if they see some irregularities in the signals. So this is our solution, and this was the previous experiment conducted at the substation. What happened here was these are these substation, electric substation, and these are red lines are the power lines. These are about 100 kV or 500 kV power. Now here they calculated that when the solar storm was at its maximum peak, then the amount of current induced was about 0.4 to 0.6 milliampere. And why I considered this in my project is because this is also a mid-latitude region, the sub-Saharan, and this will help us to know whether how topological and many parameters of the power grid affect the GIC.
So you are you are expecting similar impact in the equatorial zone and polar zones?
Yes.
Which zones it will be high?
It will be high in equatorial zone, because in equatorial zones the ionosphere is more dense due to its presence of more ions.
It can be polar side. It can be other side. So which is polar to extratropical zones, the impacts will be very high. But
Real world applications, how complex, because we don't develop it, right? Do you think we can develop a software on top of it or really applicable?
yeah, so where the industry, basically what they are looking, the amplitude sensors, micrometers. So we are looking in space, ground-based also if we have the development. So really how much it is coming to that, how much fluctuation. Basically is looking in the low frequency. How much impact is coming in the particular areas, like electric communications. So those things if we are able to characterize. So industry we can distinguish and we can give them.
Like when the experiment was conducted in Almaty, then line by line every substation last week they shut down because of the GIC and it was at its peak. Strong. It was very strong.
Thank you, that was a good one. We're covering almost everything. That was weather, power grids, almost all the lines.
I am Nitya Harushani from third year computer engineering branch.
Yeah, before you just start, Naveen, this was the topic that Indus USX, right? India they challenged DRU, and this is the solution that they are giving out there.
Okay.
So I would let that the students' real work hopefully would come out there. You should actually come back. Please go ahead.
The topic of my presentation is going to be real-time tracking of invasive satellites in the Indo-Pacific space. So basically in LEO, there are a lot of LEO satellites available in the whole region. So there are possibilities that one satellite can evade the space and signals of the another satellite. So to prevent that, what are we going to use this? We are going to use machine learning models and we are going to use sensor integration. So we will be using sensors from the data from the sensors which are there on the Earth, on the satellite, and the radar data which is going to be present, which will be we will get from the satellite on the Earth. So basically what are we going to do is first we will be taking all the data from the satellites, and we have NetCDF data which is sort of the static data. We already have the static data. The parameters which we have used are the longitude, latitude, date and time of the satellite, and the atmospheric density of the satellite. So and then what are we going to use is we are going to use API data for the real-time data, and then we will be comparing both the data sets. The data set which we have, the historical data and the real-time data, and then we will be comparing it in the form of graphs. So what I'm going to do is first we will be having a graph which is already going to be created with the historical data, and other graphs will be created using the real-time data. So if there is any anomaly in both the graphs, then we will have there is some detection of some other invasive satellite in that area, and then the satellite is going to work accordingly. But if the graphs are similar, then there is no anomaly in the data, and the satellite will work the way it is actually working. And the data sets which we will be using data from NetCDF data, then we have API data, and we have historical data. So these three are the data sets which we are going to use. And we will be using machine learning model to create all these graphs for visualization. So that is the idea which we have. And we already have a static data set ready, and we are working on, we have ISS data, static data, and we have also have an API data for having the real-time data. So we just have to fetch that data, and then we are going to work on integrating both the data sets and then work more on the machine learning side.
Yeah, this is the real problem. Satellites, somebody is giving spoofing or lot of things. Another one is with the ground-based frequencies. They are making like a same frequency. They are making as a so same frequency resonance if it is creating. So because of that reason, satellite cannot operate, or if it is operating, it will be very black with the same frequency. So this is 2-3 satellites in China. So they are whatever the opponent satellites, they are making this. So we can make little encrypted way and much more encrypted way. So we can use this as a real-time application. I think there is a lot of literature is available. So many things. Whatever solution you develop, people are countering and they are making this to take the control of the other satellites.
I think that's one way multiple. Yeah, this is a real application that we submitted to Defense Innovation Unit. So this was one proposed, and our experts had a little bit other view, as Shah said that there is something. So let's see what would be coming up. So we'll counter multiple things and give it for you to develop. Thank you.
morning everyone. My name is Chirag Samantha. I am a third year student from the Electronics and Telecommunication branch. The idea which my group is proposing to use is basically GPS chip design for NAV. And the design includes basically ASIC design, which is application specific integrated circuit. The best advantage of that ASIC design is basically it is designed for a specific task. So it offers us low power consumption along with enhanced signal sensitivity, also high performance. So that's the reason ASIC design is being used for this chip, along with Kalman filter which we are using for sensor fusion. Now sensors can be used for reasons like if we lose the signal sometimes, sensors can take the input of the signal to help us in real-time tracking. So that is one of the points which we are using. Second thing, one of the challenges which we might face in implementing this chip is multipath interference, which is basically signal reflection, which occurs due to obstacles coming in the path of the signals. So our aim is to basically design a chip which can give us low power consumption, enhance signal sensitivity, also reduce these multipath errors caused due to signal reflection, and also high performance. The second aim is NAVIC's two frequency bands, that is Alpha and S, can go good with ASIC design. So that's the reason we have selected this design along with Kalman filter for sensor fusion.
Thank you so much. The good thing is how quickly can we really go from presentations to the real world live solutions on the chips.
That's the biggest challenge which we can face in this particular project.
But we really want that if you're really performing well and passionate about it, by the time you come into final year, right?
Yeah.
These are real world problems which are really affecting the industry. If you can continuously deliver that, companies are built on this kind of solutions.
Yeah.
So that's how SM Quantum was actually doing the same stuff. So you're not getting any gap. Most of the time there is a gap between what you study versus what you work and what is needed. With this kind of education system, you can just do what is industry needed and it will be a live program. Maybe you could do a little more.
Thank you so much. Thank you so much. Thank you so much.
Good morning to everyone. So my topic is gas station in space. So there are a lot of countries who are in space missions in the long decades and many years. So it's collecting a lot of space chunks in the space, and it is also harming the other satellites which are doing missions. So our project is to reduce this space debris which is present in the orbit. So we will be gathering first of all we will be tracking the debris by using the data sets from NORAD, ESA, and then we will be using the tracking, and then we will be processing it to convert them into fuel and other resources for repair and work. So when we will be extracting this material, we will be using basic tools like grinders and crushers to break down this debris, and we will be using magnetic sorting to separate the metals from the non-metals, and to melt these metals like aluminium, titanium. We will be using sunlight, like through the mirrors, we will be focusing that to create an atmosphere for the melting process. Then we will be converting them into fuel, plasma fuel, and we will be storing it in fuel for further if any satellite or any spacecraft which is doing a mission and if they are running out of any fuel, they can use this fuel. And if there is any damage in the satellite, such as if there is a solar panel which is not working well, and if we already have that from our space debris, which wasn't functioning, but there is a part, like the solar panel is there, that we can use that solar panel and replace it with the existing satellite solar panel so that it works well. And then, yeah, so we'll be using that. So the main focus is to convert the debris which are around 1 centimeter to 10 centimeter right now in the lower Earth orbit, as most of the debris, around 70% of the debris, is in the lower Earth orbit. So we'll be focusing on that, and also lower Earth orbit is closer to the Earth, right? So we'll be focusing on that. So this is the inaugural project.
The idea is very good. But how we are going to collect the debris?
We'll be using robotic arms or maybe magnetic nets to collect these debris. Then we'll be actually the demand is
which the country needs is a space station. This is to be done in an orbital.
Orbit services.
Because it is very difficult to bring into Earth and convert it into fuels.
Because the connection is still in the conceptual.
Yeah. Many countries are still mixed.
It's very complex. The velocities which is the debris is going, that velocity you have to go and catch.
So for that,
there is a big challenge. So many concepts are coming. But immediate whatever the solutions, whatever the satellite we are launching, so there is a time frame by. So ourselves we have to deorbit it, we have to bring it to the atmosphere and burn it. So that is one solution we are adapting, at least whatever we are launching. So whatever is existing is 1 centimeter or 2 centimeter, 10 centimeter. So still some concepts are not clear. The biggest issue space.
There are few companies, Orbit Fab, which actually refuels. That is like gas station, like petrol pumping on there for cars. We have a gas station for fueling satellites. Orbit Fab does. From Indian standpoint, there is a company called Orbit 8, which is trying to do something out there. Those are the big companies. But catching the debris on orbit, Carl Morse is one of the companies who's trying to connect out there. It's a good friend. All the three founders are good friends of ours. But trying to find a solution to really make it, you're trying to make it sustainable. But again, as Sam mentioned,
this is the only biggest challenge.
Debris collection is the biggest thing. How could you really do it?
Processing is easy once you get that.
That's the biggest thing. Yeah, you can't practically do it, but this is super thinking in the next generation. Thank you. And two more from that. Let's get and I hope we have a lot of patience here.
So very warm good morning to everyone. I hope everyone is in good health. So our topic will be the Doppler-based satellite position estimation. So our topic is significant as it addresses problems such as clock synchronization, atmospheric delays, and integrating orbital dynamics and real-time signal processing. So we aim to provide a precise satellite positioning using Doppler shift analysis and addressing challenges such as atmospheric delays. And so I'll walk you through the workflow. So we will collect the data, we will collect the satellite signals using SRT and GNSS receivers, and then we calculate the Doppler shift analysis, calculate the variable frequency using Doppler shift, and then the data which we are collected can be is processed using processed to remove the errors and providing a smooth flow. Then the position estimation can be done using the Kalman filters, and lastly, to validate it, we are using MATLAB simulations for it. This provides the Doppler effect is providing us a reliable method for satellite tracking, and our project is providing a reliable navigation, better communication, and enhanced observation systems. And this will also ensure the safety and safeguard the space infrastructure.
It's good. So, how much improvement you are expecting the scales, centimeter scales?
Sir, actually we are working on it because we have the open source data, but we need the actual data.
So what is current and what you can improve, that also included. So how much you are going to achieve with this data?
So once we receive the data set, then we would try to stimulate it.
I love the way you wrote on the hand. So this is the beauty of students. Thank you. Good job. They work hard. You work so hard. Keep up. When we were studying second year, we were not like this.
Yeah.
So good work. So proud of you.
Good morning, sir. My name is Devashri Pawar. I am a second year student. So our project is solar flare detection through deep learning. So the basic idea is to create a model using CNN, and which will convert the pre-processed image from the data sets to detecting the solar flares, and then we will also are working on classifying them into the various classes like A class, B class. So what is different is we are focusing on real-time functionality by training the model again and again and using the time series images and also implementing, we have explored a bit of data augmentation. So we are deciding to integrate data augmentation into this, which will enhance the model accuracy, the general and the real-time processing stabilizers. And the data set that we have currently got are from the SDO benchmark, but we haven't gotten the real-time data set, so that's what we are working on. And the main idea is to CNN is a feature extraction, so we are going to feature extract, and then also using the time series classifiers, which will help in better classifying the image.
Good. So you have to use AI also, and because the frequency of the data sets is very less.
Yes.
So you have to train very good way.
Yes.
So not only the CNN, you have to use the little AI based advanced model because of the input data sets are very less.
Yes, sir. So that's why we were also thinking by data augmentation we could produce some artificial data
That also.
for prediction.
So synthetically we have to generate.
Yes.
So my name is Vijay Tiraj. I'm from second year advanced navigation. So my topic is enhancing the navigation GPS tracking algorithm for precise navigation. First of all, I will give a brief description about what is Navig. Should I compare the Navig and GPS? First, the Navig is our Indian satellite navigation system, and GPS is globally used. And GPS basically uses 24 satellites for navigation. And our Indian satellite GPS uses 27 satellite and give accurate position within a 8-10 meter, where the GPS give 20 meter of accurate. So this is a positive point of view. And what are the problem facing our Navig? Basically, it is not being introduced in mobile. It has another costing of hardware, and it is not so relevant in mobile. As we move apart from the India, it is not used for GPS tracking or anything. So this is also main problems of our Navig. And one of the problems are facing for slow signal acquisition for bad weather condition, atmospheric errors, and signal interference. Basically, this Navig GPS signal is introduced in 2006. Is still the research going on how to make for better. So we provide modern tools or techniques as a FFT based signal, as we fastly or quickly accurate the satellite signal. And second, we are putting a multi-phase filter in which the signal get reflected back as a river or a building. That also measured by the receiver to calculate. And second, we will put a Camden filter in which the noise or filter has been reduces. In first, mostly satellite has two major problems. First, to come to the earth, and in which the ionic sphere and troposphere, where the most of the random signals and noise are being introduced. So that is the first major problem in every GPS or system. So for the calculate, we are using kernel filter or modern techniques, and we are using the MATLAB programs. We already have the codes in PDF, so we go through it. And one of the most exciting it is the Indian. So we are so accurate to put our intents globally, and we are also given the global for globally that we have the Indian own satellite as a GPS and Galileo, and one is a Golno. So one of that is an Indian Navig system, and it is a 2-band, where is the Alpha and S5. S5 is mostly used for a military. It has a 0.5 accurate because of the military. This is wrong, and for general usage, basically we use it in not in apps but in a transportation, agriculture sector, and disaster management. And wherever the disaster management it was not accurate for in a major components are like a raft or dense forest, because of the signal has been not that accurate. So we are providing the modern techniques in this. Thank you. Thank you, sir.
So, good morning everyone. Myself Pratik Nakashi, and I am from third year IT. Our topic is development of interactive web-based application for satellite attack warning. So what we will basically do, like we are gathering the data sets from various sources and we are processing that data and analyzing the attacks which are happening on the satellites. So our major topics are cyber attacks and jamming, because through the literature surveys we have observed that most of the attacks are cyber attacks and jamming on the satellites. So we will be developing a web-based interface like which can predict and notify the person earlier than the attack, and the person can see the notification or the web-based application and he can take the necessary actions. We are using the LSTM model, like a long short-term model memory, through which it can predict the anomaly and the attack the attack only. We are analyzing the requirement. We are collecting the data from various sources. Through our API, we can collect the real-time data also.
One on the side, so and then we'll do one over. One here, and they are all kind of students, those who walk, we can study here. Sure. All students will present in this camp so that you can get a picture. Chitra, please join. Yeah, please. Pull the chairs. Full chairs, the slides. All the stickers. Yeah, please. Yeah, that's okay. So that way you get the background. Yes. Please. Please.
Yes, students, please join.
Teachers also goes over. One with students are Thank you guys. You do great work. Yeah, this side. Those who are presented can come. Yeah. This side. The presenting students. That
Presenting students.
Secondly, we would have never done that for sure. That's a very good one.
So we asked only one to present.
Yeah, that's
They've all.
yeah, the one of walking exercise. Chitra madam, please.
Present, those who presented.
How do you same. Oh, yeah. Rashid, please join us. Yeah, we'll take this way and then you can do it. So you get this. Please, come on, Rashid. Please, come in. Madam, Chitra, please. Sorry. Where are the students you present? There's one. Yes, yes. Oh, wow. This is super. Yeah, always very good. Students are always something innovative. You can't even imagine how they come up with it.
Wait, or what? One more.
Thank you. Let's go.
Thank you.
Call them up. This is what we need to do. Now, imagine what is going to take
Second session, you brought it up.
Excuse me.
our guest today. I request Abhinav to please escort our chairman, Shri Jayanti Bhai Chadwa, to the dais. I request Sidhi to escort our managing trustee, Shri Naveen Ji Bhai Shah, and Honorable Joint Secretary, Shri
so supportive personality while we work with US-India trade relations. I was here at Cyber Trade Mission. I think some of the students were also invited to join Consul General Mike's party that was actually happening over here. And he was so gracious, and he loves Shah and Kutch so much, he once wanted to study over here. But he did a great job, and now he's really building one of the amazing industry relations. So he's one of our friend, trustable partner that we could go on. Because of protocol issues, we couldn't do certain things. And this is a soft launch that we do. But I hope, I don't know how many of you are here as a faculty or others, we said that one day we will have ISRO chiefs sitting here and talk to us. I think that was a 2-year-old promise, a 3-year-old promise. Today we have the chief weather expert for the Center of Excellence. It takes time, it takes effort, sometimes we might fail, but we won't forget what we said we are going to do. So this is one thing. Let us put up some milestones and marks for the next coming days. So this center, we were working with 4 state governments. State of Karnataka, Andhra, Telangana, and Odisha. I was talking with some of their principal secretaries, chief secretaries, and even the state was paying money to start a center of excellence, and that would be run by us. Then after all, a lot of decisions we made, I personally made, with the trust of Dr. Babeji, I know that I can anytime call him and make certain things happen. I believe that this should be the first center, not an IIT, not an IIM. This is the place we can really make something happen. It's because of the leadership of Dr. Babeji and also the great students that we are always getting in. In few weeks, what they put on there is so much amazing. So we need to provide some resource to these students. So the presentations were so much amazing. So every team that was presented, we will either sponsor them for their travel to other conferences. So on a budget of around like 60,000 rupees, I think we have 8 teams that presented. 18 to 5,000 is what we are awarding and announcing for all the students' hard work. So they will be traveling out for conferences. And the second thing I wanted to share you is that the center cannot be produced without a real need and real deal. So though we have a place, facility, because the founders have already done that, instead of we reinventing the wheel, we want them to excel. This should be the point of contact. When we say we are India's first what? Anybody can start anything within a day. And it doesn't matter until you have some substantial results, something where we say this is impactful, where people recognize it. So we had a 24 months vision that we actually drafted, but you need resources for it. So on this stage, I'm proud and happy to share that we will be allocating 1 crore budget exclusively for this Space Weather Center, and that will be happening from here. And it needs effort, and then that 1 crore as a business, if you are investing 1 crore on this thing, you expect a 10 times your return on it. And in the hub and spoke model, while we run this from this center, this location, we would want to go around and push it on to other states. We will be partnering with one university from every state in India and then create this research excellence, go up into the next level. At the same time, we need international partnership. Today, you might have seen Chitra from Western Australia over here, Naveen from US was up here. We want some of the best universities to come and collaborate with us, probably joint master's PhD program. And when we are infusing a lot of money and time, energy into this, that is the metrics which we will be calculating. 24 months, 12 months from now, we want the alerts and insights that are being created here, not only used on this, but we go. As a company, we don't want to just have a PowerPoints, we don't have patents, we just don't want some working prototypes. We want a product that is being used at the end site. So if you are building it from this location, then we are successful. So this is the place that I was betting from 5 years. Even though there are hiccups, there will be certain things which we did not know, but we will definitely make this as a continuous process. And we have seen students going out and getting some stuff. One important metric I want to share is there are 39 students that actually worked along with them. I think roughly 11 of them are almost in US. 4 years back when we did not have anybody, right? Few of them got their OPTs, they're working, they're doing some nice projects. We wrote a letter of recommendations for many students. This time, what would be the advancement after 5 years is, we will get them admissions right here. The program after 2 years, right, second year, third year, final year, they will be continuously working on certain things, because now we are autonomous. That's a privilege that we can ever get. Earlier we had a lot of restrictions, so now we will design, define and play things in such a way that we will take this to the next level. We were grateful to have great mentors like Dr. Rajshekhar ji. He will be interacting with students post-lunch just to get on some real working prototypes. And there is another brain which we did not get out there. When you hear from from Ashish, Ashish knows in and out of Indian space things. If you see any articles, any related brain, his PhD work and his international exposure will be the space policy making guy. So he knows every single company, what are they doing in India on the space side. He comes from Indian Space Association. So we combined these things in such a way that we had Australia, US, India, along with industry partners and then the real end customers. We want government officials to come to this place. I mean, when I say international government officials, trying to say that this center is doing some amazing work. So we will be watched by every other things, but there are few pointers that I want to give out here. We consider IP very critical. We have our values, integrity that we actually work on. We really deliver things that we are going to do it, and we will be working hard. Innovation and all these 4 factors will bring us successful. The biggest success for us is to have the first person of the country to come to the campus and say that we are doing amazing job. Whether it is 24 months, 36 months, if we can't do it even after becoming autonomous, we are not doing our job. We don't do our job just for money. We do it because with passion, we will deliver certain things and we will bring. The tag of first in the country has to be earned. It is not just a given piece. Let us earn for this thing. And I'm very proud and I have a lot of confidence on the faculty, the amount of time you put, the kind of PhDs that we are generating, we will be one of the best. Though we build Institute of Eminence, let's get that process from here. Let's have this founder's vision and mission in a partnership nature. So these are the people that I could bet on and say that not IIMs, not IITs, not bigger universities, I want to do it from here. That's how I started it. We made the decision and it is you who has to really implement it and make it possible. Any kind of problems, we are here to support you guys. Propose what is needed and we will support you. Once again, thank you so much for this. There is a bigger thing and longer goals and objectives we need to accomplish. We all will be watching this. Thank you so much again, Saki.
So rather thank you Shrikant sir for putting up all this hard work and support and helping us to set up the first space prediction center over here. Thank you sir very much. And also for motivating all our staff and students who have been running around the clock for getting this work and the projects done. Thank you sir. It is my honor to welcome our guest of honor, Dr. Rajshekhar Meka, scientist and chief meteorologist at ISRO. Sir focuses on space launch and recovery and specializes in weather forecasting and climate studies. Sir holds an MS degree from International Space University and has studied remote sensing and space science, atmosphere and planetary sciences at Andhra University. Sir has participated in UN, ISRO and IRS workshops on space technology and has received IEEE appreciation for his work on climate change. Sir has developed significant expertise in weather, climate studies and natural disaster management, and he has over 20 years of experience in helping and providing critical solutions through data-informed decision making. It's our honor to have you here, sir. So could we please hear from you? I welcome Rajshekhar Meka.
Morning all. First of all, thanks to Speaker and getting blessings from the founders to where it could cause non-profitable education society is imminent. We know the education is so well. If you learn the teaching, whatever the teachers are teaching is any student, if they benefit from the college, their lifelong they remember, and it's a great service as I feel. And thanks to all the principal, the faculty, and Chitraji, of the friends which is assembled here. And the basic, you guys knows the satellites which are majorly influencing everyday day-to-day activities in the globe, and which is experienced by India also. And here, everywhere, every time we are listening about the satellite and its applications. So the main cause where the looking for the space weather monitoring. So the major things, whatever the extremes or the hazards we are, because of the sun activity, we are experiencing in the equator, whatever the tropical region is much lesser than what we are experiencing the extratropics and the polar regions. So basically I will touch the few points about the space weather and its hazards. So you know the sun is the big source of energy, and the composition of sun everybody knows it. So because of the changes in the chemistry, whatever the orbital mechanics and the orbiting of the sun, the solar flares and the CMEs, mass ejections, the storms. So in Earth we have the storms, similar way we have the storms in the sun. So because of the sun, the storms have the lot of radiation ejections. There will be radiations. Because of the storms, we have the mass ejections are huge. So these cycles are maybe around 10 years, the decadal ejections will be there, very high level of ejections. But there will be a small scale of ejections. It can happen every day, it is happening every week scales. But the scales of increasing this mass ejections is a 10-year scale, the frequency is increasing. So it can come in 5 years or 4 years or 2 years. You know the space assets, the space rockets, whatever we are sending the satellites to rockets, and you might have heard the space-based internet. Okay, so the Elon Musk, the SpaceX is sending the satellites in the low Earth orbits, 10,000 scales. So 10,000 satellites are monitoring the space situational as well as the for communication, the space-based internet. They have been orbiting in the low Earth orbit, is ranging from 400, 500 kilometers to 700 kilometers. So the assets of space-based assets are increasing very high, and you know the radiation because of the space weather injections, solar storms, geometric storms, which will directly affect on the space-based effects. So the increasing the, where one of the students, very good student presentation has been seen here now. So they have been showing that the increasing the space solar activity will increase the currents. So increasing the intensity of the currents and the undulations in the currents which can damage the satellites. So those are the major concerns. So if you know early about the storm is coming, so we can switch off the satellites, we can protect the space-based assets. So in spite of that, these solar storms are coming, penetrating to the ionosphere. The ionosphere, it is transforming to the lower, the regular scintillations, whatever the irregularities of the electron density is passing and impacting on the power grids and impacting on the telecommunications. So the recent the solar storm in the May 2024, which had the large impact recent years, whatever we have seen. So similar like where we are, everybody is using the positioning, the GPS signals, everybody using. So because of that, so whatever the storm, it is having the disturbance on the GPS signals. So if you are using the, now everybody we are using the cabs, everybody using the GPS signals for the navigation. So it become our day-to-day life. Like our, what are the machineries, like precision tractors in US or the agriculture machinery, like John Deere company, they have the precision agriculture they are using with the automation. All the in the fields by the John Deere through so the farmer sitting at the home, they can operate their the tractors or the trucks, whatever the things on the fields, they will use the automation of GPS based things. So these type of signals where it is getting the interpretation or whatever the interference, where we are getting irregularity of signals, sometimes it can stop, sometimes it can give the wrong signals. So we are so dependent upon the navigation system, so the space weather will impact, sometimes it will disturb. So it can cause the loss, it can create the stopping of the activities. So these type of activities coming to the ground and space-based systems. So because of this space-based hazards, it's influencing. So for that, we have the different satellites and different prediction systems we are having in the place, where the US-based, European Space Agency-based, as well as the Australian-based and Indian-based, we have the satellites which are being observed regularly, and based on these observations we are using the prediction models which can give the predictions for next 3 to 4 days, and beyond for 10 days we are going to aim it. So using of AI based, ML based, where one of the student is presenting that we are having the data and making the understanding how it is going to come. With the using of the AI, we can improve the prediction skills also. With that, so in India, the first time the initiative is coming with our Srikanth as well as Saket, where we are going to make, this is the thing, first time space center. It can monitor and give the prediction, and going for the not only space-based assets, ground-based, which is going to impact on the power grids or GPS signals or precision agriculture, precision mining, precision, what are the applications we are being used for the navigation system. So where this prediction sector is going to work for it, and it is proud that first time the team is going to work on this type of applications using of the global data, Indian data, and the prediction models, so which can give the very high resolution temporal and as well as the spatial resolutions, where we can give the space-based weather forecast. So thank you for everyone giving the opportunity. Hope the children, the students and the faculty going to work for this cause, and our support is going to be there with us. Thank you.
Thank you, sir, for that very motivational talk. Next up, we have Nashik Chaudhary ma'am and Chitra ma'am. Ms. Nashik Chaudhary is the Investment and Trade Commissioning for Mid-Gulf Interest and Trade, Western Australia. She has nearly 2 decades of experience in investment, trade and economic development across states, local governments and Commonwealth. She holds a Master of International Business degree from Monash University and has extensive expertise in managing offshore networks. Ma'am is being joined by Chitra George ma'am. Chitra ma'am has served as Business Development Manager at various primary industries. She has led comprehensive industry coverage, strategic initiatives and many product developments. She has completed advanced certifications of international business from London School of Economics and Political Science. So now I hand over the session to Chitra George ma'am.
Good morning everyone, and I would like to, on behalf of our office, congratulate Saket and also Srikanth on this inauguration day. I would like to request to play a short video which basically talks about the Western Australian space capabilities, and that's pretty much self-explanatory. Thank you so much.
Rocky Ham, you're saying there.
Thank you, Chitra ma'am, for sharing this video. So now we know that Western Australia is also into the space battle, and it's good to see that there's so much that happens in a space center. Thank you, ma'am. Joining us again through a recording today is retired Lieutenant General Anil Kumar Bhatt, Director General, Indian Space Association. He has won various awards like PUSM, UYSM, AUSM, VSM, and he was former DGMO during 2017 Doklam crisis and has overseen operations neutralizing 259 militants. He is the first Director General of the Indian Space Association. Sir is being joined by Mr. Ashish Kumar, Lead Consultant ISPA. He is into research and development, and he's also pursuing his PhD. He's an entrepreneur and is into business consulting and educational consulting. So over to you, Ashish sir.
Hello and good morning to all. Thank you to Shrikant sir and the college for giving me the opportunity to speak here. I am representing the Indian Space Association. Lieutenant General Bhatt has a message for you all. I would like the AV team to play that video.
Distinguished guests, esteemed colleagues, senior faculty members and students. It is my privilege to address you today at this momentous occasion as we inaugurate India's first Space Weather Protection Center here at Shah and Anchor Kutchhi Engineering College, SKEC, in collaboration with Blue Space. This center represents not just a technological advancement, but a strategic necessity for India's growing space capabilities. As the Director General of Indian Space Association, I am particularly encouraged to see this center being established within an academic institution. The Indian Space Association pledges its full support to this initiative. We see this as a model for future industry-academia partnerships. And we are committed to facilitating similar collaborations all across the country. These will not only serve as a research facility, but also as a training ground for the next generation of space scientists and engineers. The integration of Space Weather Protection Center with SKEC's curriculum will create a unique opportunity for students to engage with cutting-edge space technology and real-world applications. The establishment of this center marks a crucial step forward in developing indigenous facilities to protect and mitigate these impacts. Space weather prediction is not merely a scientific pursuit. It is a critical component of our national infrastructure. Solar storms and space weather events can affect everything from satellite communication, power grids, to navigation systems and defense capabilities. As India's space sector slowly expands, with private players launching satellites and developing sophisticated space technologies, the need for an accurate space weather prediction becomes increasingly vital. I congratulate SKEC, Blue Space, and all partners involved in bringing this vision to a reality. This center is a testament to India's growing capabilities in space technology and our commitment to develop world-class infrastructure for space research and applications. Thank you. and I look forward to a groundbreaking work that will emerge from this center. Jai Hind, Jai Bharat.
On that note, I'd like to reiterate that and congratulate Shrikant sir and the founders of the university that what they've done here is a pinnacle because he is walking the talk with respect to the industry academia collaboration, and we'd like to see more centers of excellence being developed in India. And congratulations again, and I hope to the students to make use of this center of excellence. So I hope to see you in the field. Thank you.
Thank you, Ashish Kumar sir and Parth sir, for encouraging us and always supporting us. It is my privilege today to read the profile of Professor Divyendu Chakravarti, Head, Space and Atmospheric Science Division, PRL. Sir has been awarded with the prestigious Vikram Sarabhai Research Award in Space Sciences in the year 2015 for his excellence in space research. Sir has extended his exceptional contributions as principal investigator on major space missions like Aspects on Solar Aditya L1. Sir has been contributing significantly towards developing and mentoring the next generation of exceptional scientists. He has supervised 7 doctoral and 11 postdoctoral students so far and has been serving on 18 doctoral committees. Sir, it is indeed a blessing to hear from you today. I request Professor Divyendu Chakravarti sir to please address the gathering. I request the AV team to please shift to the team's mode. Thank you.
That sun is in every aspect of life, sun is very important. Without sun, we will not be able to live a life on this planet or maybe in other planets in the solar system. So today, it gives me a great pleasure and privilege to talk in front of you where students, faculties and dignitaries are sitting here to inaugurate probably India's first private sector driven space weather prediction center. And why space weather is needed at this stage, maybe I'll highlight a few pointers here, and so that it helps you to understand that why it is a necessity in today's world. And as we increase our technological prowess with time, with a lot of satellites and space assets in LEO, GEO, and other orbits. And we have our planetary missions lined up in the past and then in the near future. It is more important that we need to know that as we navigate through space, what kind of environment that we will be encountering and how we are going to mitigate them. And therefore, if you look at India's space heritage or space development, space science and technology development in the last couple of decades, you will see that we started with the Chandrayaan mission, and initially it started from the rocket flight from the Tumba rocket launching station in the 60s in the southern tip of Indian peninsula, where we first started with the rocket flight from Tumba. We studied ionosphere, and then eventually Aryabhatta came in, and then there was India's first satellite named after the famous mathematician that India has produced. And then after that, we have in the recent times, in the past 2 decades, we have conceived Chandrayaan missions. We have gone to the moon 3 times, Chandrayaan 1, Chandrayaan 2, and Chandrayaan 3. And in Chandrayaan 3, we made a significant jump in terms of landing our rover on Chandrayaan 3, landing a rover on Chandrayaan, on the lunar surface. In addition to that, we have Aditya L1 mission, where we, understanding the importance of the sun in space weather, we have launched Aditya L1 mission. And this mission is going to give us very important data although the official lifetime of this mission is 5 years, but a mission of this kind generally can survive for much more than 5 years, much more than that. I'll not be surprised if this mission survives for 15, 20 years or so. So it's a time when students and technologists and scientists, professors, teachers, academia, industry will be getting the data not only from NASA and NOAA satellites who are pursuing this space weather forecasting activities for the last few decades, but also from the Indian satellite, which is Aditya L1, and you can take data from there and use it. Making hands with each other and making forecasting framework that can not only help protecting our space assets, but if you look at the activities that are lined up in future, we have Chandrayaan series of mission, Chandrayaan 4, Chandrayaan 5 that are being lined up in future. We're going to land our astronauts on the lunar surface in near future. We'll also have a Bharatiya Antariksh Station by 2040, and that's the plan that India has. Now, every such activity, every such initiative that India is taking today, at every stage of this development or this plan, space weather prediction plays a very important role, because unless we know the medium that we are navigating, we are putting our assets in, it's like you're traveling on a road, you need to know the traffic conditions and you know that whether any kind of dangers are coming in, what is the weather there. If you're driving from Mumbai to Pune, you need to know that if it is raining heavily or if the weather conditions is good or bad. Similarly, if you're traveling from Earth surface to the lunar surface or maybe on the planetary surface, you need to know that which medium are you traveling in and whether you can make a prediction there. Because eventually human being is going to travel, going to become interplanetary species. I mean, so not only will be sending our vehicle or space vehicle to other planets, but also at near future, we may be seeing that human being itself will be traveling to different planets and other surfaces. So therefore, space weather prediction is going to become a very important part of our ecosystem. Now, space weather is a subject where it's highly interdisciplinary in nature, and in order to have a prediction, you need to have support from scientists, you need to have support from engineers. They need to understand each other's language quite well, and then not only engineering discipline, in engineering itself, you have multiple disciplines that will be coming in, not only the electrical engineering, electronics engineering, engineering discipline will be handy in developing a tool which will help us to navigate this medium. On the other hand, if you look at the scientific disciplines, There are ionospheric physics, magnetospheric physics, solar wind, and then planetary sciences. All these disciplines, we need expertise from all levels. And therefore, it is important that we talk to our next door experts and to understand that how a comprehensive solution can be brought in. It's a very early days as far as Space Weather Prediction Center in India is concerned. There are some activities in some of the government labs is going on, but in terms of its industrial interface or how this data can be shared with the industry, so that after the space sector reform, the kind of industries and startups that are coming in, they will be using this data to for their operations and things like that. This is what the objective is. And therefore, Space Weather Prediction Center is a very appropriate step that has been taken at this point of time, and it's the correct time. And we need to leapfrog at this stage to come to a level where we are as competitive as, for example, NASA or NOAA. NOAA does the space weather forecasting in US. And so we have a long way to go. But I think we can leapfrog by building an ecosystem where scientists, engineers, and other expertise they come in, and industry and academia they work together. This is something which should be our motto from this point onwards, and therefore this initiative can help us to build such ecosystem. And I would like to invite the expert and experts as well as the students to really jump in and then try to see that in what way your expertise will be useful to building such space weather prediction capability in our country, because this is what we are going to need in the coming decades in order to be more competitive, in order to be more technologically savvy. That's all I want to say. So this is a very good initiative, and I wish all the success of this initiative. I also thank the Shah Saxi Institute, Shah and Anchor Kutchhi Engineering College to host these activities. And this is a wonderful advanced level of thoughts that has gone into it. And so I wish all the best to all the institute faculty as well as the students and and the Blue Space founder Mr. Srikant and his team. And I'm sure that this initiative will become a grand success in the days to come. So from my side, once again, all my best wishes to this great initiative. And I think it is very, very contextual. And we need this in our country in the coming decade. So therefore, all the best to the efforts that are being taken at this stage. And thank you very much for inviting me to deliver this, to share my excitement with you and today morning, which is a very special day. And at this day, the Space Weather Prediction Center is being inaugurated. Thank you very much. Thank you.
Thank you. Hello, sir.
Hello.
Yes, sir, you can start.
Okay. So, yeah, good morning, everyone. And my apologies for not being there in person, but thank you, everyone, for inviting me on this. And especially congratulations for setting up the first Space Weather Prediction Center. And congratulations to the Blue Space, Srikanth, and the university and everyone who have been involved in this one. So to give you a brief introduction again, I'm Sirish Pallikonda, Vice President of Skyroot Aerospace. And to bring you a little bit about this Skyroot, I will share a small presentation. Just a moment. I hope you all can see my screen. Can somebody respond? Like, are you able to see the screen?
Yes, sir, we can.
Okay. So Skyroot, with a vision of opening space to all, we started in 2018, and by Pawan Kumar Chandana and Nag Bharat, who were previously scientists at Indian Space Research Organization, and they started Skyroot in 2018 with a focus to provide affordable, reliable, on-demand, and versatile launch services for the small satellites. And and we are the first company from entire India to launch a rocket to space, and we did it in 2022 November with our Vikram S suborbital launch vehicle, and also the only startup in India to win two national prestigious national awards from the government of India for the startup award and the technology startup award. And currently, Skyroot is having a team of more than 350 plus, and currently valued at $527 million. That was last round, so it's almost like 1.5 years back. Now the valuation has grown up. Yeah, and these are our launch vehicles. We call them as an Vikram series. So all these launch vehicles are made of composite motor casings and also honeycomb interstate structures. And this launch vehicle consists of solid liquid propulsion technologies and also cryogenic and earth storable propellant. So if you see Vikram 1 is of an earth storable propellants at the top, the upper stage. Rest of the other three stages are solid propulsion, whereas Vikram 2, the upper stage is cryogenic engine, whereas the rest other three stages are of solid propellant. And also all our engines are 3D printed and quite modular in design. So this is
Sorry to
our place in history with Vikram S, which we launched in November 2022, as I mentioned. And this test was mainly carried to test our avionic systems, solid propulsion systems, aerodynamic and trajectory, and composite structures and thermal systems. With this particular study, we could prove 70% of the tech which goes into our orbital launch vehicle. And our orbital launch vehicle is scheduled to launch in Q2 2025. So we are in the preparations to get everything ready in that direction. So these are some of the state-of-art facilities what we have at Skyroot. So we have in total 260,000 square feet facility which is available. And yeah, Just a second. Hello. Oh, just a second. Is it any better now?
No, sir. It is unshared now.
Okay. Just a second. Is it better?
Yes, sir. You can start slideshow, sir.
Yeah.
Full screen.
I'll rather have it like this.
Slideshow.
This one? Are you able to see the screen slide?
Hello.
Yeah, are you able to see the screen slide?
Hello.
Hello. Hello.
Hello. Yes, sir. So slideshow can start.
Yes, I started the slideshow.
Okay, thank you. You can continue. Thank you.
Okay, thanks. So as I was discussing, these are some of the slides which I have took through. So yeah, we are the first company in India to launch a rocket to space, and the current team of more than 350 people and the valuation of 527 million, which I mentioned in the slides. This is how our rockets look. Okay, so you can respond to me in case if you have any issue, if the slides are freezed or you are not able to see anything, you can raise it right away. So yeah, these are the launch vehicles which I have mentioned. This launch vehicle is Vikram 1 and Vikram 2. It's an fully solid propellant rocket and the upper stage with a liquid engine and cryogenic engine. So Vikram 1 has an liquid engine, whereas Vikram 2 is having a cryogenic engine, and both the engines are 3D printed. And it's quite modular in nature. That means the Vikram 1 stage 1 means this particular part can go as a stage 2 to Vikram 2. So the number of parts that need to be manufactured would be quite less, and we will be able to produce a launch vehicle every month and also integrate to launch it within 24 to 36 hours. And this is our Vikram S launch, which we have done in 18th November 2022. With this, we proved our avionics systems, solid propulsion, aerodynamics, trajectory, carbon composites, and thermal systems, etc. So 70% of the tech has been proved through this Vikram S launch vehicle for our orbital launch, which is coming up in next couple of months. So this is some of the media that been showcased, and these are the key investors. We have Temasek, GIC, and Meraki Labs, and all. They are mainly from Singapore with the majority of the capital which has come, and also we have Greenco and Solar Group of Industries and Ram Shriram, who was also an early investor into the Google, and he is also board member at Google, and World Quant Ventures, Graph Ventures, AUM Ventures, and all. So this is a little bit about Skyroot Aerospace, and how is this a launch company relevant to the today's discussion. If we see the Space Weather Center is something even very important for a launch company, because before the launch we want to understand what are the weather conditions and everything, and also launch operations. Okay, when we do it, we need to have an specific analysis which need to be done, and it is called as an LEOPS. Under LEOPS, like, we need to take the space weather report for launching this thing, and also it becomes quite critical and important for all the customers who would be on board our launch vehicle. So in our maiden launch, we have almost 12 to 14 customers, both international and domestic customers. And based on our mission profile and what is that they're planning, they need to have this space weather prediction properly analyzed, and based on that their mission planning would be done. And most of you might be knowing, okay, because of the solar peak in 2025, some of the satellites which have been planned for like 2 to 3 years would have their mission life reduced to 6 to 8 months. So such a loss of efficiency to 30% is in great would be a great disaster to those satellite companies. And that is where space weather centers are something typically very important for launch companies as well as the satellite companies. And having this initiative, I greatly appreciate again the institution and also the Blue Space for taking this up. And I wish you everyone a great success in taking this forward. And probably we take a lot of space weather data from the future. And if any questions, yeah, please let me know. Yeah, thank you very much.
Thank you.
Thank you. Now I request our principal, Dr. Bhavesh Patel sir, to kindly felicitate our guest, Mr. Kumar Vadapalli, Director BES Space. I request Kumar sir to kindly come up on the dais.
Thank you, Principal Sir. Thank you, Kumar Sir, for joining us and giving us your valuable time. The house is now open for questions. We invite questions from the students and the faculty fraternity. Students, if you have any doubts, you can raise your hands. We'll give the mic to you.
It's more of interactive sessions. We always do this. So we specifically wanted to hear from you. We might have ambitions. India's first won't become world's best or nation's best without your support. So any challenging things, we can always reach us out. So our numbers and contacts are out, and we'd love to hear some questions. So we can go after this and get back to lunch. I know we are the ones who are starting here, and we also want to facilitate you. Feel free to throw out some questions. We are almost here. Any questions, any concerns, or what do you think? Please go ahead.
Is GPS chip design for NAVIC. So our main challenges are arising it as multi-path interference. So what are the techniques we can use to reduce this?
Even the signal interferences, whatever we are using the frequencies. So we have to use the filters, but the disadvantage again, how much you are increasing the filters. But digital filters we have to use and reduce, where we are getting the common filters and then the predictive filter, whatever we are adding. So that way filterization is more important. There we have to use the electronic, not than the electronically, we have to use the computationally, we have to use the filters and reduce the noise because of the interference.
Thank you, sir.
Questions will not to be just technical, it could be operational or the leadership wise. How do you envision? Any questions can be asked.
Hello sir. Our project was real-time tracking of evasive satellites of Indo-Pancom space, and my question was that how do we handle lost or sparse data while handling our project? Because there might be some sparse data which are incomplete. So how do we handle that? How do we overcome it?
Again here, if you have the past data of your whatever the satellite track you are having, and what are the conditions you may lose the satellite tracking data. So where we can have the we have to use the machine learning we have to do with the past data, and in the future what are the orbits where it is supposed to go. So those orbits, the fusioning of this data, then we can make as a prediction.
Okay, sir.
Any other questions? Your seniors left the country to study, but at least for your standpoint, we want to have a joint things over here, or you get the degree, same stuff, without spending 2 years, 3 years out of the country. Those days are gone. A decade ago, people were going out of countries to study, but now you get the same degree, you get same experience, and things are all quite different. Majority of things are on here.
Yes, you can ask questions.
Yeah, open for faculty questions, any area. Please go ahead. Thank you.
It's out of curiosity how Sunita Williams, they were supposed to return by 1 or 2 months, still they are stuck in space. And what is the reason for, just to know by curiosity, what is the reason they are not able to come back, or why we are not able to take another spacecraft and bring them back? Or they are willingly staying there for any out of research or something?
No, this actually, they have been flown with some other company. You know, the ISS is previously by NASA rockets, they used to go from Russian rockets, the Soyuz, they used to go. Now, you know, the Elon Musk Dragon capsules. So similar like that, another company they have been sent to them. And they found some issue with the capsule what they gone to return. So which is, safety is the higher priority. So that they discarded it. And next one, another one has to go. You know the space program, if you want to quickly, like not like our Indigo flights, we can book next flight into this. So it will take the minimum 1 year, 2 years to plan the missions. So where our Indian astronaut is flying. So he has flown to the US 6 months back, and next coming few months they are going to fly. So there is a series of program and training and the testing of the missions. So the planning of the mission will take. So that's why maybe the delay, maybe in the 6 months it is possible they are doing much effort, because they got their system got defected. It's not like by NASA missions. So that is a delay.
Send another spacecraft to pick them, but how in space, how they will be able to come out from this and get into another spacecraft?
No, they are in the ISS. So ISS, so whatever the spacecraft which is docked to them, they can come back. So they are in this common platform. So they are going with the different rockets, different capsules, but they are staying in this together in there, in ISS.
Any other questions, or are we good to wrap up, please?
From electronics and telecommunication engineering department, what is the as we are now having autonomy, so the curriculum changes that little bit of tuning towards the things we have to do. So in that direction, what are the steps that we have to, and what are the courses that we can use?
One of the objective which I feel, whether you are mechanical, electronics or whatnot, So I think this was the discussion we were having in with Ashish out there. In India, we have 85 space companies are listed that are members of ISPA, around like 100, purely space-based. Yeah. But space actually needs support from mechanical, electrical, and whatnot. So if you're specifically talking about the subjects and application area, if you're working closely with our weather prediction center, you can actually focus electronics, focusing on that space division out there. Those kind of, if you are doing some multidisciplinary program, we can emphasize a 3 credit hour subject or something like that, which actually goes in. Whereas the whole program is a completely different story. Now you wanted to work specifically from your department, how closely can you solve the real world problems with ECE? Instead of just teaching them, let's call a couple of companies that are specific onto the ECE without, it's a 2-part question. One ECE with space, ECE with industry. So if I were you leading that ECE division or somebody, I would exclusively call that 5-6 companies which are really working on it. Adjust your curriculum accordingly. One of the biggest challenges that I found in the US when I was starting a university is the frequency to change the curriculum, because it's a rigorous track. So you need a dynamical way of changing the curriculum with the industry advancement. Industry advancement is fast and quick, whereas our educational thing is a little harder. So you need to adapt those change, and autonomy might give, I think Dr. Bhaveji can actually give better way with the rules and regulations. But I think we want to lead in such a way and go. But of all 10 subjects that gets you a degree awarded, you can play with 1 or 3. Specifically, I studied in the same way, whereas I was an ECE, electrical and computer engineering student, but I wanted more of entrepreneurship. So I did 6 of my subjects in one way, 4 of them were doing completely independent. In the 4, I did 10 subjects, water, finance, accounting majors does. Same way in electronics also, you can come a little bit creative. I think those directions, I think we can work and figure out. There are some good companies. We will allow to work on this center. So we are not specifically calling like BES is the only company. We want more companies. There is some metrics that has been established to bring other companies to support this center altogether. So we'll come back, and then that's a nice way of thinking.
Thank you.
Any other questions?
Hello, sir.
Yes.
This is Dr. Shashikant Rarke. Sir, actually our group is trying to work on one project like space debris tracking system or their possible dangers. So from the past data, they will be working on that. But now, if we have to get the live data or want to track the debris dangers or what you can say collidness from the live data, what are the possibilities to get the live data for that?
I would say it's hard but not challenging or impossible out there. We can get that. But there are few companies like Planet, privately, Dr. Moribaza, who is doing a good work on space debris and other stuff. We can get it, but we need to
There is a NORAD, so one of the students also presented to us. So NORAD data is open. So
Okay.
and the 2 line element data you can use, and near real time you can monitor. And if you want extra things, we have to buy and we can integrate them. But for research purpose, NORAD data we can use.
Okay, sir. Thank you.
You heard from the right guy, so then you know the answer. But if you want a private industry thing, then it's a completely different story. R&D should be handled.
Thank you, Rashtrika sir and Shrikant sir, for giving us those wonderful insights.
Just a minute.
Hello, sir. My question is related to mapping of the satellite images with mobile images. Because whenever we want to do prediction regarding weather, that time we won't be able to accurately predict the specific area. So in such type of cases, if we can take help from localites, and then if we could map those images with satellite images, then I think we will be able to do the prediction. It won't be just related to images only, but with the help of other type of parameters also that can be done easily. So would like to know your views on this. Thank you.
Yeah, it's a good point. You know, our mobiles are monitoring the weather. Our aircrafts are monitoring. We are flying. Our aircrafts are also monitoring it.
Yes, sir.
So this in Europe and the US, what are the aircrafts which is flying? So they are near real time. They are collecting the data and going to the models for predictions and observation also. And same way, mobile data also is upcoming. The temperature and the pressure data is going to the models, and it will be useful for the predictions. So like a situational awareness with our hands, whatever we are having, the mobiles, the cameras, so all the data will go, is now thanks to the AI and ML models, so which can fusion all this data into the required models, and the predictions are going there. So this is called hyper-local weather prediction as well as the monitoring.
Okay, sir. Thank you.
It's going to happen.
Yeah. Thank you, sir. The further questions we can be addressed during the networking lunch. To reach to this historical day, there has been a team of faculties who has been giving their hard work and all their heart and soul to this. I would like to request Shrikant sir to please felicitate few of our faculty members who have been working day in and day out. May I request Bhushan Pawar sir from Department of Advanced Communication Techniques to please come on the dais. I request Shrikant sir to please present sir with a felicitation. Thank you, Bhushan sir, so much for your hard work.
So just so that you know, Bhushan sir actually attended all of the in-space courses, and he started STAR program that ISRO was actually doing out there. So continuous projects, continuous work. He will be also attending Space Law program that InSpace is about to publish. So we wanted to train the faculty on various activities. So thank you so much for doing all of this work.
Thank you, Bhushan sir. I request Swati Suchak madam from Department of Computer Engineering to please come forward.
Yeah, we heard that Swati ji is the creative mind. If you see something that was built on the lab area, she spent a lot of time on it. Thank you so much for that.
Thank you, Swati ma'am, for the beautiful illustrations out there. Next, I would like to invite Professor Seema Kawale madam from Department of Advanced Communication Technology. Thank you, ma'am, for the constant coordination and constant guidance. I would like to invite Professor Deepshika Chaturvedi madam from Department of Computer Engineering. Thank you, ma'am. We have been seeing you on your toes since the time the project competition was announced, and the way you have really kind of guided our students for the Project Expo. Thank you, Deepshika ma'am. Thank you, sir. The resilience and the hard work demonstrated by our students for their project is truly remarkable. Students, here we have a big surprise for you. May I request Dr. Rashika Meka sir to please felicitate our students for their projects. First, I would like to invite Sanjana Shimpi and her group for the project titled Space Weather Monitoring Package. Sanjana, can you please come up on the stage? Thank you, Sanjana and team, for the excellent demonstration. Can I request Gurdev Singh and his team to be ready? Next, I would like to call on the stage Gurdev Singh and his team for mitigating GIC project. Thank you, students, for the showcase of your endurance and the wonderful research taken by you. Nitya, can you please be ready? I invite on stage Nitya Bhanushali and her team for the project titled as Real-Time Tracking of Invasive Satellite in Indo-PACOM Space. Good work, guys. Students, you can get down from the right side of the dais. Chirantan, please be ready. We welcome on stage Chirantan Samarth and his team for the project titled GPS Chip Design for Navy. Chirantan and his team. Students, we request to come down from the right side of the dais. A big shout out to Chirantan and his team for the wonderful work done. Panyuta, please be ready. We invite Panyuta P and her team on the stage for the project on gas station in space. Good work, guys. Sanskriti and her team, please be ready. We invite Sanskriti Chavan and her team on the stage for the project titled Doppler-based Satellite Position Estimation. Good work, students. Devashri, please be ready. I invite Devashri Pawar and her team on the stage for their project on solar flare detection using deep learning. Good work, Devashri and your team. Abhijit, please be ready. We invite Abhijit Ethiraj and his team on the stage for their excellent work on enhancing NAVIC GPS tracking algorithm. Manav, please be ready. I call upon the stage Manav Kothari and his team for QNB band antenna. Yashwant, please be ready. Good work, Manav and your team members. We invite on stage Yashwant and his team for his project on wearable antenna. Parth and team, please be ready. Thank you, Yashwant and team, for your wonderful work. I invite on the stage Parth Karan Chawane and his team for the excellent work on non-GPS NAVIC. Pratik and team, please be ready. I invite Pratik Nakshe and his team on the stage for their work on GUI interface for ACW. A big round of applause for the students who have been selected and who have not been selected for their wonderful efforts. Thank you, Rashtriya sir, for encouraging and motivating our students' team. I now request Professor Nabratam Nam to come on the stage and propose a vote of thanks.
Good afternoon, everyone. I take this privilege to present the vote of thanks on behalf of Vidulata ma'am, Dr. Vidulata ma'am, that is the HOD of Computer Science, and myself, who have been the coordinators of this event. I would like to extend my heartfelt gratitude to our management, Shri Jayanti Bhaiji, Shri Naveenji Bhaiji, and Shri Mansu Bhaiji, for their continuous presence and support in making today's event a grand success. Special thanks to our visionary principal, Dr. Bhavesh Patel sir, for his unwavering guidance and support in organizing this event. I would like to express my sincere appreciation to all the dignitaries who took time from their busy schedule and attended this event. sincere thanks to Dr. Rajshekhar Mika sir, Ms. Chitra madam, and Ashish sir, and Naveen sir for taking time and gracing this event. I thank Ms. Nashid and Anil Kumar, Director General, and Professor Devyendu and Shirish sir for joining us virtually with your good wishes and insights for this monumental moment. A special mention of Mr. Shrikant sir, whose efforts have been a glue binding us all together to make this event an astounding success. I would like to acknowledge all my teaching staff who, though were not felicitated, but have been working really hard, especially the technical team and the broadcast team who have been working really very hard for what we will be seeing YouTube live and the recording. I express my sincere gratitude to the students of Research Cell and the creativity team. So Swati ma'am was not alone. She had a big battalion of students who were working since past 15 days to make this event a grand success. So thank you to those students. I hope everybody has witnessed what kind of creativity these students have done. But I would also like to mention that these project students, whatever you all saw, was a result of only 2 weeks. Means precisely 10 days, because New Year's nobody worked. So in 10 days, what these students have got, so we all can just hope what my students can get in a year. So I would like to, all students we have already felicitated, but a good round of applause for all these students. They have worked day in and day night to bring this all to reality. And then again, the faculty team is always supported by the big battalion of students. The creativity team and my administration team, you all have seen they have been behind every guest and they are always there for the support. So let's continue to push the boundaries together. With this note, just one small felicitation to the administration team of students who has been working really hard, and I would like to take their names. So Research Cell President and the support admin, Diya and Ankit, can you have on a dais please? Shrikant sir and Bhavesh, yes. Sir, both of you please. Please. And Rajshekhar sir, if you could please join them. Chitra ma'am, please. Ma'am, students will be very happy to have it from your hands. Creativity team, Jasmita and all be ready. Jasmita and team. Creativity.
Yes, please, sir. Yeah, one more. Thank you.
Second up, I'll call the entire creativity team, whatever you all have seen in the lab, under the guidance of Swati ma'am, Jasmita and team. Jasmita, Naitik, Hetal, Tanish, Arpit, Neel, Bhavya, Shravani. Swati madam, you collect on their behalf. You can let them know that their names were announced. I think creativity's team is still busy in the Space Weather Prediction Center. I'll announce the names again. Jasmita, Naitik, Hetal, Tanish, Arpit, Neel, Bhavya and Shravani. Next, I would like to call Deep and Pradnesh. They have been behind the project students arranging their repeated reviews, and the result is in front of all of you, because any project doesn't come out so nice until and unless reviewed repeatedly. So in this process of 10 days, with the support of Deepshika ma'am and Gauri ma'am. We have been able to take repeated reviews, Bhushan sir, and then the result is in front of all. We today have seen the witness of the launch of the website. This website was created within one day. Shrikant's idea was yesterday, and today you see the website live. So I would like to felicitate the person knows who it is. Aryan, can we have you? It's Aryan Gala. It's his work in action. He made a website within one day under the guidance of Swati ma'am.
Yes, sir.
Swati ma'am, Vaishali ma'am. Vaishali Chauhan ma'am, because there are so many Vaishalis. So next up is the event admin team. Vrishi, Danvir, Diya, Samruddhi. Can we have you all up on Shlok? Vrishi, Danvir, Diya, Samruddhi, Shlok. Param, hop on the stage.
You are ready? Yes, please.
Proud moment for them that they have been part of this historic event at Saket.
Thank you.
Some of them have become product managers of large companies. 5 years from now, you will say that you are doing something, and you should be supporting the center. There are some distinguished alumni who are always supporting. Proud of you guys.
Auditorium team, Dilip, Nilay, Arya, Kairavi.
So come through.
Now comes the main part, the reception and hospitality team. Siddhi, Sachi, Abhinav, Paridhi and Mrunali. Paridhi. Last but not the least, my photography team, Arush, Tanvi, Himanshi and Rusha.
Yeah, please. Thank you.
Thank you, dignitaries. So as we have been doing Saket has been covering several milestones. This is one more feather in our crown. And let's continue to push boundaries together. Thank you. I would request all of you to raise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे, गाहे तव जय गाथा। जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे, जय 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 हे।
Thank you all the dignitaries for blessing us with this wonderful day. I request the volunteers to please escort the dignitaries to the first floor.